Okay, so we're nearly there with session 6. We just want to now use linear interpolation to estimate the value of the error function evaluated at 0.2396. Okay, and we're going to estimate the value of the error function at that value using a linear interpolation routine we've already created, and also our numerical integration routine, which we're using to calculate the area under the curve e to the minus x squared, which gives us the error function. Okay, so if we now go into MATLAB, if we make a note of this number, we can go into MATLAB and we can use it. Okay, so let's set that value at, let's say h equals that value. Let's not use h because h is reserved for trapezium width. Let's call it m. That's the value. That's the value we're going to try and estimate the error function for. So we can do it exactly in MATLAB. We can say L equals m, and we get 0.2653. Okay, let's now do it using linear interpolation and our numerical integration. Okay, so let's evaluate the error function using our numerical integration at 2 points. Let's evaluate it at 0.2 and at 0.3, and then we'll use interpolation to find this value. Okay, so if I use the up arrow, I can go back, I can make V1 error function evaluated not at 1 but at 0.2. Using that trapezium width, so that will give me a value for the error function at 0.2, V1, and then I can do the same, but I can evaluate the error function now at 0.3. Let me call that V2. Error function at 0.3. Now I can use linear interpolation to evaluate the value of the error function at that intermediate point, whatever it was. We've called it m, 0.2396. Okay, so at m. Okay, so I can say that L2 equal to, remember it's lin underscore interp brackets. Helps me by telling me what the input arguments are. So my input value of x is 0.2. Y1, that's equal to V1. X2 is equal to 0.3. Y2 is equal to 0.3286. And finally, I want to interpolate at this point n. L2 I get 0.2646. The exact value for L is 0.2653. So a reasonable approximation. Of course, we could do it all again with a finer trapezium width, and we get a more accurate answer. But we'd never get a perfect answer because we're interpolating. So remember, interpolation assumes the function is straight, but in fact the error function is curvy between 0.2 and 0.3. So we'd always get an error in our estimate. But I hope that these set of screencasts have illustrated some important features with MATLAB functions.